Thank you everyone for joining and coming to this webinar about maximizing the benefits of real-time traffic monitoring. We're going to talk about or look at the system itself. Not only that, but as I said, we've got our special guest for speaking today from Telelink CITY, who's going to give us a real in-depth experience of what they've had and what they've done during the testing or POC or their project that they've used the system with. And they're going to really give you that insight of how simple and easy it's been to implement and the kind of things that they've done in the system. So we're going to really talk about that. At the same time, my part here, I'm going to give you an idea of the GoodVision product itself, the real-time monitoring, exactly what it is. And then we'll go into maybe some of the questions and answers and so on. So let me just click here. So this is the guys that are on the call today. As I said, we've got Mladen, myself, and Daniel. So they'll be able to take your questions. They'll be able to speak with you on anything that you might have. And let's get straight into it. So the GoodVision system has now, well, not now, but has put in live monitoring. We have a product called live monitoring, and it's got the real-time ability to give you the ability to take data from an intersection and give it straight to the platform, a GoodVision platform that you're used to, or to any kind of control system you've got. So we're looking at the areas that the real-time traffic monitoring is looking at here with traffic data collection. So, you know, at the minute it's slow and it's manual. It's very static. The data that is setting these systems is just not adaptive. It's just some kind of from simulations and from old historical data, and it's set in the system. And also the driver of these areas is price as well. It's quite expensive to have something going 24-hour on the system. So if you look at the transport modeling area, so this is the area that we're looking. It's very time-consuming or extremely time-consuming. Simple tasks are very costly, and these are the drivers and the capability that we're going to be looking at. So when we're looking at the GoodVision real-time monitoring itself, the product is part of the platform in the sense that you're adding the ability of your cameras to become a sensor and look at real-time traffic detection, but customize that area in the sense of speeds, volumes, or you're looking at any kind of data that you want continuously feeding into either a database or sent to the system that you're going to see and how that was done. And many of you might have also seen a YouTube link where we have this with the camera that is attached to our either device, which is a small black box, which we're going to go into further. You'll see exactly what that is and what it does. And this device is then doing all the computation and the live kind of processing on that device, and then it is dispersing that information in real time to any kind of platform or system that you require, or to the GoodVision platform where you do your analysis later on, if you want to do any further kind of in-depth analysis. And then the area that we've got here as well is the traffic control. So not only with the modeling area on seeing what's going on the intersection, whether it's getting too much queued up or there's too much traffic in an area, and what can you do to improve that. But if we look at the traffic control also, it's a part that's, as mentioned, instead of having a static information that's going to your control center, you can now have a very adaptive real-time input to these systems and these sensors from the GoodVision Live software that is then providing this data for your systems to make controlled and informed decisions. So you're able to see this and kind of experience this on the GoodVision platform. You can take a trial and you can upload video to the system and look at all the data that you can extract from that, from a kind of not real-time perspective straight away, but it gives you an idea of the type of data that you can obtain. And then we're able to do that in a real-time manner in giving you this information with the devices attached to cameras. The best thing about the system is that it's not costly in the sense that you have to get extra equipment or equipment from us, should I say, not extra equipment, because you can put it into a infrastructure you might have, and you might need to do some improvements on some of the hardware that you've got. And in the sense of the cameras, they're a bit more better quality. Although on the tests and the POCs we've done, we've also used not so brilliant cameras, and it's still able to do the detection. It all depends on your projects, on the areas you're covering, and so on. So you're able to really quickly set up things like this very easily by putting in the device, connecting your cameras, starting your analysis, and getting real-time data straight away. So what I'm going to do now is hand this over to Dan. He's going to maybe talk a bit more about the industry and some topics here. He's going to go a bit more in detail, and then I will be handing it over to Mladen and so on. So I'll just pass the mic over.
Yeah, thank you, Chris. Hello, everyone. Also, welcome you to the webinar. As you know, dealing with traffic is an inimitable but yet frustrating aspect of life. So, but fortunately, there are smart management systems or smart solutions that can help address these challenges, and helping to get us individuals, when we're commuting, to get from the point A to point B safely and efficiently. And this is what we're going to speak about today, or what our guest will be going to speak about today, about a practical experience with it. Today, I know cities have been increasingly turned into real-time traffic data collection and real-time traffic understanding to help prevent and decrease commuting times, prevent congestions, deal with various situations like accidents, and create congestion based on the accidents. And that's with a good reason. So I'm happy that I can invite today our special guest, Mladen Zamanov from Telelink CITY. Hi, Mladen, who will be sharing his practical experience with the implementation of GoodVision Live Traffic technology into their traffic control system, specifically in project in Stara Zagora in Bulgaria. And I would like to introduce Mladen more deeply, if you let me, Mladen. Mladen we are cooperating together with Telelink CITY since 2019. We started with traffic surveys, and right now we are working together on smart adaptive traffic control systems, where we are integrating our solutions together using them. And Mladen is the alumni of the Delft University of Technology with a specialization in transport planning. He's working with Telelink CITY, which is a former ITS department of Telelink, the big city integrator company in Bulgaria, in Sofia, Bulgaria. And Mladen was involved in many implementations of traffic management systems across the largest cities in Bulgaria. One of them, Stara Zagora. And his specialization is in micro simulation, traffic signal control design, and he's a graduate of smart technologies in his department. So Mladen, again, thank you for joining us today. And to give you a first question and to start this conversation rolling, let's do it in a more interview style. Could you please start and go ahead and introduce Telelink CITY to those that doesn't know you yet, and what type of projects are you involved in?
Hello, Daniel, and hello, everybody. Thank you for introduction.
You're on mute.
I'm muted. Can you hear me?
Yeah, we can hear you now.
Okay. So thank you, Daniel, for the introduction and for having me for this webinar. Can we go to the next slide?
Yep, sure.
So Telelink City is part of the Telelink group, and we're a system integrator that are focusing on smart city solutions in several cities across Bulgaria and Romania. Our basic topics are the traffic management as well as public transport management. In the public transport area, we have an automated vehicle location system, real-time passenger information system, as well as a ticketing account-based ticketing system. And we see this whole the combination of these systems as a very good backbone for future mobility as a service platform for our clients. So we started in 2017, and we have about 18 clients in Bulgaria and Romania. Regarding the traffic management, we are combining products or solutions from several providers and vendors from Bulgaria as well from outside Bulgaria. And this is also how we got to know GoodVision. In the traffic management sector, we have experience with a lot of different types of detection technology. We use a Bulgarian produced traffic controller for our projects, and we have also developed our own public priority system that we offer to the clients in order to improve the speed and to reduce the delays for the public transport. Can we go to the next slide?
Yeah, Mladen, here, if I may jump, sorry, there's an echo. If I may jump in with a question. This is weird. And I mean, I would say that I guess the first thing that everybody is interested to hear for the start is like, what was your initial motivation? What you started looking for any type of like smart solutions in the traffic control or traffic video analytics area, especially. So tell us more about in what way your current solutions were limited, because of course you were using some sort of detectors. So tell us more about it.
Yes, as I said, we had experience with different types of detectors, including inductive loops, magnetic sensors, as well as video detection. However, I would like to call this video detection some kind of old school video detection. And if I may shortly introduce how it works, basically, it uses background subtraction. And as you can see here on the image, it calibrates the background, and then each frame, it detects if there is something new in the image. And this is how they get these white blobs or contours on the third image, on the black and white image. This system works, but it has some major disadvantages that we saw with the years that we used these detections. We have some shades, rain, fog, or snow that reduce the accuracy. You can imagine that if there is rain, that the background is not always really clear, and it is difficult for the algorithm to make to subtract the vehicles and the objects that we are interested in. Also, depending on the mounting of the camera or the video detector, there are sometimes false calls from larger vehicles that are moving in the adjacent lanes. You can imagine that they somehow shadow the vehicles in the next lane, and the algorithm couldn't recognize the vehicles, the smaller vehicles in the adjacent lanes. Also, basically, the detector doesn't know what is this white contour or area in the image, and it could even not be a vehicle, and we would still count it as an object that moved through the detection zone. Something else also, that we were actually getting information about the detection zone itself and not about the object that we're interested in. So let's say we get if the detection zone is covered with an object or not, but we don't know what is the object, what it is doing there, and how much time it spends on the detection zone. Here in these two images, you can see example of these zones that I was talking about. And even here you can see that some of the vehicles are not correctly detected by the algorithm, and that's because of the maybe the building to the left makes a shadow on the car, and the algorithm couldn't recognize it, or something else.
So these gray areas means that, like, these are the zones where you detect occupation, and there is a car, but the zones remains gray. That means it's not detected. Yeah,
sure. Yes, correct. The green, when they turn green, it means that the vehicle is detected, and when they stay gray, it means that there is no detection. So we miss this vehicle actually.
And if you miss these vehicles or these events that you're capturing, what is it causing for you? What does it mean for your system? What do you do? How do you fill up the empty space, or we don't know that there is something?
What we did was to actually manually calibrate the counts. We tried to estimate what is the expected error based on some conditions on the image and the camera, and we added some scaling factor to get to the correct counts and correct data actually.
Okay.
And yeah, this is why we decided to look for something better and something that can increase the accuracy of the detection and the quality of the data that we get. So the GoodVision Live Traffic actually uses deep learning based object detection and tracking. The algorithm detects each object and calculates its central point or centroid, let's say. And then the other algorithm is able to track this object throughout its movement in the frame. And this way we get these really nice trajectories of different objects. And moreover, we are able to classify the objects as trucks, buses, vehicles, or people and bicycles even.
Okay, and what convinced you actually? Because I guess you've been looking for multiple types of solutions out there, because video analytics is a very attractive industry, even though that most of the suppliers that we know that are stopping here in this point, that they are just providing the data, nothing else. But what convinced you actually to choose GoodVision to integrate with your systems and take it to your customers?
Yeah, it was that it is easy to implement, and we had very good cooperation with other projects, and I was sure that we will be successful implementing this pilot project.
Thank you.
Yeah.
Yeah, I see that you're jumping to the pilot project already, which is probably the most important, most interesting part of today's presentation. I would say that the number one question I'm getting when I'm talking to different customers is, and no matter what type of webinar we have, if it's about surveys or control or modeling, the number one question always is, what is the required camera infrastructure, quality, and so on to run this system? And also, will it work with my existing camera infrastructure? Or So can you tell us your own experience, what type of infrastructure, what setting you used for the project?
So this is exactly what we did with the pilot project. We selected an intersection where we had already some pre-installed IP cameras, and we wanted to know if we could get better results and accuracy with these cameras without additionally adjusting them or moving them to other infrastructure or steel constructions at the intersection. The cameras that we use are some basic cameras with 2 megapixel and 25 frames per second. And this was perfectly enough for the accuracy and for the detection to work in a way that we needed it to work. The most important part of this system is actually the device that runs the deep learning models. And for this pilot, we used NVIDIA Jetson Xavier powered processor. That is a small device that can be installed in the traffic cabinet, which is, you can see the image on the image, that is the traffic cabinet that controls the intersection actually. And we also have our public transport priority controller that is also able to get the data from the detectors. Something very crucial for the traffic actuated control to work is that we have a very low latency, let's say less than 1 second between the event actually happening and the controller getting the detection alert or the event. In this regard, there are 2 types of connections that we usually use. It is a fiber optic connection to the server between the server and the controller, or a 3G connection. We wanted to test both type of connections to see in what situation and what available infrastructure is better suited for what solution that we can use. From the experiment and the pilot tests, we saw that if there is a fiber optic connection between the cameras, the traffic controller, and the server, then it is better to place the device that runs the deep learning models in the server. However, if we don't have this fiber optic connection, then we will use the 3G, and then we need really to put the device as close to the controller as possible. This is the cabinet provides perfect protection from the environment for it. It controls the temperature, so it was the right place to install the edge device and use it for the traffic control. This is a picture of the project solution architecture. You can see that we have the cameras, IP cameras that are connected by a router to the device that runs the GoodVision Live Traffic. Then the results from the GoodVision Live Traffic are sent to the Telelink device Telma. There is a REST API between the 2 devices. The messages are just simple JSON format and very simple to read from our device. Our device then transforms these messages in the format that the traffic controller requires it, so it can use and do further the actuated control on site.
Mladen, and which are actually the most important traffic parameters that you needed to catch by the system to feed your Telma system that controls the controllers? Can you somehow elaborate more on also on comparing it to what you used before, or to some traditional solutions you have used?
Mm-hmm. So basically, the most important thing that we need is the detections on the zones or the lines that the crossing sections that we define in the image. Also, it is important to have the speed as well as the classification of the vehicles that are moving on the streets. It was also important for us to add another level of control by analyzing and getting the data about pedestrians and bicyclists as well. And on this slide, you can see examples of the setup for the GoodVision solution that we used. At the time of the project, that when we did these designs were made by your colleagues, but we then discussed that it could be better for the future applications that each client can define the zones and the lines the way they need it exactly. Also from these images, you can see that the cameras are not really perfectly placed, and there are some zones that are not well covered. And this is something that people should have in mind in future installation, that they should use the cameras and place them depending on the needs of the data they need. And the better placed the camera, the better results they will get.
Yeah. Yeah. Also, you're right that during the pilot project, which started at the end of last year, this configuration of the events and detection was done, or detection zone was done as with the configuration files to the scenes. Right now, this is of course available, so you can remotely set up your scene from your GoodVision Video Insights app, as well as check the remote devices just for the record. So yeah, let's move to I wanted to ask. I see that you also have a video, so I will just keep my question for the later.
Mm-hmm. Can you play the video, please?
Sure. Thank you. Turn your hand off.
Also, another important information that we get from this system is the queue length that is accumulated on the stop bar and in each lane. We also can see how much time each vehicle spends in the zone. Because these vehicles are they all have their IDs in the system, and we can get the exact time and the exact delay each vehicle has have on the intersection. This way we can later analyze and evaluate how well the traffic control works actually. Yeah, you can see how the pedestrians are also detected, and how each vehicle has its own trajectory, and how when it crosses the line, we get the event of the detection.
Okay, and what probably the most important thing, even if you like the system or not, is what were the benefits actually that it brought to you, or especially to your clients or to your future clients? What do you see the benefits of this? Can you share some results?
Mm-hmm. Yeah, can we move to the next slide, please? Yeah, thanks. So in this table, I tried to summarize the advantages and disadvantages of all different technologies that we have experience with. The inductive loops and magnetic sensors have very high initial and operational costs, as they need construction works to put them in the pavement. Although they have very good accuracy, they cannot measure speed or classify vehicles that are passing without additional sensors or additional setups for them, which furthermore increase the price and the cost for this type of detection technology. The traditional video detectors that we use have much lower initial and operational cost, but with this also comes the low accuracy numbers that we observe. They also are not able to classify speed, to measure speed or classify the vehicles at the moment. This way, we came to the solution of GoodVision that provides the benefits of inductive loops and magnetic sensors that have very high accuracy, measure speed, and classify all types of vehicles in combination with pedestrian and bicyclists, which is not possible with the inductive loops and magnetic sensors at the low cost compared to the that is comparable to the traditional video detectors. As a conclusion, I can summarize our experience with this technology, that it is very easy and flexible for installing and using, as we use off-the-shelf devices. We don't have to develop anything by ourselves. We just need to receive the message and send it to the traffic controller. The integration is also very simple based on this REST API that we used. We got very high accuracy, above 97%, and this was even with this not perfect setup of the cameras. And I believe that if we take more into account how we place the cameras in future, we can get even better results. Of course, I explained that with fiber optic, we get the events very quickly to the traffic controller, which was very important for the actuated traffic control. We have several multiple deployment options with the server or as an edge device in the traffic cabinet. There are also added value to this system that we get a lot of additional data that we couldn't get previously, which we can use for further developing traffic control logics that we couldn't use until now, as well as analyzing the results of these traffic control measures that we take at each intersection individually.
Okay, thank you, Mladen. I was going to ask actually if you, like, there are many parameters that you can get today from various solutions, and many solutions in traffic control solutions don't really count with it because they were not used to get it. So they were relying on counts, maybe on some, stopped vehicles or double parking and so on. And I was going to ask if you see a potential in traffic control integrators or manufacturers being able to or willing to increase the feature sets and provide more, and if it helps them to create like more types of like interventions to the controller, to the intersection, if they have more granular data or more information about what's going on, if it's, I don't know, accidents, near misses, if it calculates some traffic measure parameters like continuously, like saturation, capacity, and so on. So you just answered that. But yeah, I think
for sure. The way that we get the new types of data that we didn't have previously, traffic engineers and the system providers can work on developing new innovative ways to manage traffic with this data. And I think this will be the next thing that we will develop using this rich data that we can get from a system like that.
Okay, thank you very much, Mladen, for this presentation, which we tried to do it in a more like an interactive way, that we wanted to push the slides forward using the question and answers, and I'm passing the word to Chris again. So here's your mic.
Hi everybody. So I was quiet during that webinar because Dan had the mic, but it was really interesting to see what you've shown us here, Mladen, because there's a lot of things that the industry keeps seeing about smart cities, smart technology. Everyone talks about the smart word and all this real-time actually implementation, but we never see it that much on how easy or how simple it is to add it into a POC, and you've shown here, as you said, it's off-the-shelf equipment that you can get hold of, or we can, be sent, and you implement this, and it's the REST APIs, which is very easy to connect to other systems. So it's not a very complicated and expensive investment to get that kind of done compared to traditional methods. Or also these days, what I see is that there's a sensor for everything. So you have to have then multiple sensors, multiple pieces of equipment just to get like another set of readings, where GoodVision I see, and where we want to drive that to is having your camera as a multi-sensor. It's able to collect multiple pieces of data instead of having these huge posts with about 25 different devices on, or your, some tracker on the car or so on. So there's a certain level that GoodVision want to push to the heights of getting as much data and squeezing as much of that data from a scene as possible. And it's very interesting to see for myself, because, I work with lots of clients that are looking to implement this and always asking me that question of, how do we do it? What do I need, and what are the parameters? And this is exactly a good eye-opener for what we've seen. So thank you again for that. We can open it up for any kind of questions people might have. I see that there's something in, is this the chat? Let's have a look. Or is this just me? Okay, so yeah, this is just an internal question. So if anyone's got a question now that they want to ask, please do. We're here. If there's anything that you'd like to know, or what Mladen has spoken about or mentioned, or something you have some interested in, please do let us know. We still have some time. If not, we have been receiving questions as well, registrations and so on. So as usual, we will send out the kind of script of questions that have been asked, and then replies from ourselves and from Mladen. And also you can always get in contact with either of us here, Telelink CITY. Again, thank you, Mladen, for attending. If you've got any questions on the systems they used, please, we've got their details here. You can contact us as well, and also Mladen, and vice versa. He can direct you our way if you need to know any more information about the GoodVision Live monitoring. So thank you everyone for attending. I'm just going to check the Q&A one more time. Nothing there. Everyone's scared. Okay, don't worry. We'll answer the questions that we get from the registrations. So thank you, everyone. It was great speaking to you all, and see you all on the next webinar. Bye.
Thank you. Bye.
Bye-bye. Thank you.